this looks a bit blurry to me, so sorry about that, but we are going to do question 6 from paper 1, another question which lots of people made a decent start but then weren't able to really get all the way down and get the full 8 marks. So let's just read it to start with. So we've got f of x is 4 cos of x over 2 plus 1, and we've got a kind of slightly bigger than normal domain here. We'd normally be thinking 0 to 2 pi, but this goes up to 6 pi. And find the values of x for which f of x is greater than 2 root 2 plus 1. So again, this is slightly unusual as well, that we've got an inequality here, not an equal sign, so we'll have to deal with that a bit later. So essentially we're being told f of x, which is this, is greater than 2 root 2 plus 1. So we'll start off with trying to simplify this down. So we can cancel off the 1's, we can divide by 4, and so we get cos of x over 2 is greater than root 2 over 2. Now I think at this stage it's probably easier to say let x over 2 be theta. Okay, so we've got cos of theta is greater than root 2 over 2. And because we've changed our variable there, we need to also think about that effect on the domain. So we've got, from up here, we've got that x is between 0 and 6 pi, which means x over 2 will be all of those, both those endpoints over 2. Now, x over 2 is our theta, so theta will be between 0 and 3 pi. And that is important, but we do need to consider the domain to make sure that we're getting the correct values. Alright, so let's go back to this. Cos theta is greater than root 2 over 2. Now let's forget about the inequality for a minute and just think about when is cos theta equal to root 2 over 2. This is one of our key values. So you might have just memorised these, but you might need, like me, to actually work them out. So when is cos theta root 2 over 2? So I tend to draw out the first quadrant of the unit circle here, and remembering that the x value here represents cos theta and the y value represents sine theta. So I've got my kind of 5 key values when theta is 0, when theta is pi over 2, that's 90, and I've got pi over 4, pi over 3, and pi over 6. So I know that this point here is my 1 over root 2, 1 over root 2. This is where they're equal because there's symmetry. Just move that there so you can see it. And then here I've got my y value, I know that is half, and the x value is root 3 over 2. And here I've got my x value as a half, and my y value is root 3 over 2. Now, root 2 over 2, if we rationalise the denominator of 1 over root 2, that's actually the same as root 2 over 2. So 1 over root 2, if you multiply the top and bottom by root 2, you get root 2 over root 2 squared, which is 2. So 1 over root 2 is the same as root 2 over 2. So here we've got our value, it's pi over 4. So cos theta equals root 2 over 2 when theta equals pi over 4. That's going to come in handy, but actually now I want to start considering this whole domain that I've got and thinking about it as an inequality. So the next thing I'm going to do is draw a diagram. Okay, so carrying on from there, and I've just drawn out the graph of cos theta. So it starts at 0, and the domain theta from 0 is 1, and then when it goes down to -1, that's when we're at pi, and back up to 0, 2 pi, because obviously we've got a period that have 2 pi. So this value here is pi over 2, this value here is 3 pi over 2, and then I've carried on the curve for another kind of half, which takes us to 3 pi. and I've stopped at 3 pi because that is our domain. And this bit here will be 5 pi over 2. So then I'm looking for when cos theta, first of all, when does it equal root 2 over 2? And we know that's when we've got pi over 4. So if I've got root 2 over 2, here it touches at pi over 4. Then I want to keep on going over here, and I've got another 2 values where it equals pi over 2. But now I'm starting to think actually about what I really want is when it's greater than root 2 over 2. So this part here and this part here is when it's greater than pi over 2. So can I figure out these values here? Okay, so now I've got my highlighter. I can see I've got cos theta is more than root 2 over 2 here, when between 0 and pi over 4, and then again over here. And basically, using this symmetry, this is going to be halfway between 3 pi over 2 and 2 pi. So this is 3 pi over 2 and 4 pi over 2. Halfway between those will be 7 pi over 4. So you might need to take a bit of time to figure that one out. And then halfway between these two will be 9 pi over 4. So, solving for theta, I've got that cos theta is greater than root 2 over 2 when theta is between 0 and pi over 4, and then again when theta is between 9 pi over 4 and 7 pi over 4. Now, we've done a lot of work. It should feel like we're finished, but we actually need to give our values in x. So I need to change these back to x. So this is x over 2, and this is theta is x over 2. So I've got 9 pi over 4 and 7 pi over 4. Can't really see that, sorry. And then pi over 4 and 0. So before I'm finished, I need to multiply everything up by 2. So multiplying up by 2, I'll just change the denominator instead. 0 times 2 is still 0, and again here, multiplying everything up by 2, I'll just change the denominator instead. So my final answer here are those two inequalities. Let's just take a look at the mark scheme. Okay, so just taking a quick look at the mark scheme, this is the answer we got, which is good, because that's the same answer. It actually says here equal to. I'm not 100% sure why this bottom inequality says x is greater than or equal. Oh yes, I do know why that says that, and we should actually change our R1 as well, because here this is part of the domain and it is still greater than root 2 over 2, whereas here it's equal to it. So yes, that should be less than or equal to. You can see you've got the same diagram that we had, and well, different complicated mark scheme there. There's also a second method where you don't, no, that's part 1. Oh yeah, so that was method 2, where you don't actually change it to theta, and method 1 was the one we did, where you actually replace x over 2 with theta, I think. Okay, that's that one then. So this is our final answer. That's what you'd need for all 8 marks.